A growing body of evidence also supports adipose tissue as a key player in immune regulation. Far from being passive storage units, adipocytes interact intimately with resident immune cells, such as macrophages, T cells, and B cells. These interactions are context-dependent. In healthy lean adipose tissue, immune cell profiles are predominantly anti-inflammatory, supporting tissue repair and insulin sensitivity. During chronic overnutrition, however, immune signaling shifts toward a pro-inflammatory state. Still, this shift is an adaptive attempt by the body to deal with metabolic stress and not a failure of adipocytes per se. Understanding this immune metabolic crosstalk reveals that fat cells are active mediators of immune tone, capable of switching phenotypes in response to environmental or nutritional signals. Perhaps the most surprising and forward-looking discovery is that adipocytes share many features with stem cells and possess regenerative potential that is only beginning to be appreciated. Adipose-derived stem cells, ADSCs, isolated from the stromal vascular fraction of fat tissue, can differentiate into a variety of lineages, including osteoblasts, chondrocyte, and even neurons, under the right conditions. These multipotent cells are being investigated for their use in regenerative medicine, ranging from wound healing to neurodegenerative disease therapies. Even mature adipocytes themselves, though terminally differentiated, exhibit remarkable plasticity. Under certain physiological conditions, white adipocytes can transdifferentiate into beige or brown-like adipocytes, cells specialized in thermogenesis or heat production, through uncoupling protein 1, UCP1. This adaptive conversion allows adipose tissue to fine-tune systemic energy expenditure, further linking fat cells to the maintenance of metabolic flexibility. As we age, the role of adipose tissue becomes increasingly pivotal. Aging is often associated with a redistribution of fat, shifting from subcutaneous to visceral depots, which correlates with increased disease risk. But it's not simply the presence of fat that drives dysfunction, it's the loss of adipose tissue plasticity and communication. Healthy adipose tissue, especially subcutaneous depots, continues to buffer metabolic excess, secrete beneficial adipokines, and modulate immune responses. Preserving adipose function with age may be one of the keys to delaying age-related diseases such as type 2 diabetes, atherosclerosis, and sarcopenia. Moreover, strategies aimed at rejuvenating adipose tissue through caloric moderation, physical activity, or pharmacological agents that enhance beige/brown fat activity are showing promise in animal models and early human trials. Importantly, the negative consequences traditionally associated with adipose tissue, such as inflammation, insulin resistance, and metabolic syndrome, do not stem from the existence of fat cells themselves, but from their dysregulation. This distinction is crucial. It opens the door to therapeutic paradigms focused not on the reduction of fat mass at all costs, but on improving fat tissue function. This includes promoting healthy adipogenesis, the formation of new fat cells, enhancing adipokine secretion, and maintaining depot-specific distribution. Even weight gain, when composed of well-functioning subcutaneous adipocytes, may be metabolically benign or even protective compared to visceral or ectopic fat accumulation. In this light, adipocytes should be recharacterized not as liabilities but as adaptive, responsive, and essential components of the body's internal ecosystem. Their roles span energy storage, hormonal regulation, immune modulation, and tissue regeneration. They possess stem-like plasticity, respond to systemic cues, and can adapt to changing physiological demands. Instead of focusing solely on fat reduction, future approaches to metabolic health and aging might be better served by targeting adipocyte quality, depot health, and intercellular communication within adipose niches. The future of fat biology is not about elimination, it's about optimization.